Can you guys hear me?
Yep.
Awesome, perfect. Thanks for coming. You saw that I was recording this, so if you want to go back and go from there or watch anything that we're doing, you can watch it later on. I'm just going to go through the questions in order, but please don't hesitate to stop me if you ask a question about that, because often if you've got a question about it, then other people will, so we'll do that. And then at the end, after I do every question, I'll stay on here, and if you have some specific questions about maybe something from homework or something else, then I'll gladly answer those questions too. Okay? Anything before we get started? No? Looks good. Okay, so the first two questions in our review were ones that I said that you can either answer on the sheet or in Desmos. And I just realized now that I posted it, but I hadn't posted it for you to do the review questions in Desmos. I'm going to guess most of you will just do it by hand because it's right there on the sheet. But if for whatever reason you want to do these questions in Desmos, then you can. So the review questions, the Desmos activity is the exact same two questions that are number 1 and 2 under review. So I'll just point that out right now. So you'll see that it actually lines up with the review that's there. And then you can see that that graph is the same as the first question on our review. Right there. So I just wanted to give you both options because we used both options when we did it live. So I'm giving you both options there. And then when we move on to do the sketching, again, when we move on to the sketching, then we would have the same sketch there. And you could use Desmos to sketch, or you can just do it by hand. So totally up to you. You have that option. I'm going to do it by hand. So that we're here, and but of course it'll look the same on Desmos. Okay. Also, you should see that question 1, 2, and 3. Oops. There we go. Question 1, 2, and 3 are all Unit 1, and then as soon as we get to question 4, we're into Unit 2. So that's important to know. On your test, the front page is all Unit 1. And the back page is all Unit 2, just to help you understand what you need to do. Okay, so I'm going to go off and try and find which one is the derivative and which one is the original. So for me, I like to look at the degree of the functions because that's going to give me a clue. It's not a guaranteed, but I see that number 1 looks like a cubic and number 2 looks like a parabola. A parabola is 1 less degree than the cubic. So my gut is that number 1 is the original and number 2 is the derivative. That's my first guess, but I want to get a little bit more information before I confirm that. And that's when I'll look at the zeros. So if number 1 is the original, I should, wherever the original has a slope of 0, a tangent of 0, then the derivative should cross the x-axis. And I see that it's happening there. And it's happening here. That slope is 0, which means the derivative would cross the x-axis, and it does. And that's enough for me to be pretty convinced that the first one is the original and the second is the derivative. A third bit of counter argument is pretend that number 2 was the original, which means if it was, there would be a 0, and the other one would have to cross at 0, and it doesn't. So there's a counter argument which actually proves your original idea that it works. Okay. And then as I go off and do the next one, again, I think I see this U-shaped one as to the power of 4 and the cubic as a power of 3. So my gut says that 3 is the original and 4 is the derivative, but I'm not sold on that. That's just my first guess. I'll go off and do the pencil test. If this is the original, then that would be a 0, and the derivative would cross at 0. That's true. So I feel even more good about it. And then my counter argument is pretend that this is the original and there's the 0, but the derivative doesn't cross at 0. It should. So that is my counter argument, which makes me feel even stronger that I have the right collection here. And then this one is a little bit harder to see because I'm not entirely sure what this shape is. I think it's an x to the power 4 and an x to the power 3. So my gut is the original is 6. Because that looks like maybe an x to the power 4. And then this is the original, but going to the zeros is going to help me. Again, if it is the original, there's the slope of 0. It crosses there. Good. Here's another slope of 0, which crosses. And it looks like maybe it even does another one here and crosses. So those are all good arguments. My counter arguments, if I guess the 5, here's the 5, there's the slope, which is 0, and you see the derivative does not cross. So again, the counter argument proves that I'm right. Any questions there? All right. So now I'm going to go off and try and actually sketch them. So think back to our game where we were all sketching them in teams, and then you did some sketching on your own. Use some of the strategies we use there to say, okay, I know what the original is, I know what the derivative is, or what the shape of the derivative might be, and then go from there. So for example, in this first one, I see that it looks like a parabola. So I'm going to guess that the derivative is going to be a straight line. But let's go off and actually do some of the drawing. So the zeros are really helpful here. This original graph has a minimum down here, which means the slope of the tangent is 0. So my graph, my derivative should cross there. Then I'll do my pencil test, and this will be a little bit hard for you to see on the screen. I'm holding my pencil up, and I'm seeing that the original, the derivative, the slope of that tangent is negative, and it's pretty big. So that means I'm probably going to be down here. And then as I move along the axis, my slope gets smaller and smaller and smaller, but still negative, which means the points are getting smaller and smaller and smaller and smaller, but still negative. Okay, still small. And you see I'm underneath the graph. That's why I'm in the negatives. So let's do this until I get to 0. Then my pencil moves off, and I start to get positive slopes. And they're not very big at first. They're pretty flat. So the numbers are small. But then as I go along, they're still positive, but they get steeper and steeper, which makes me believe that it's going something like that. And I've got then a basic shape of my curve, and I'm going to go off and draw the derivative. Now, this is probably going to get me full marks, but I'm going to notice that I know a little bit more about derivatives than I did when I did this last week. I know if the original actually is x squared, if this is an x squared, maybe minus 3, the derivative, so if the derivative is 2x, right? I know that from all the experience I have now. So I might just look at my graph and say, is that a 2x? And to me, this looks a little bit too steep. So I'm just going to adjust my graph slightly to say, make it more look like 2x. So 2x would have it go here, 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 here. So I think that's a more accurate graph. But remember, you're just estimating. So maybe this graph is a little bit skinnier than x squared, which would make the graph steeper. So if you guessed the original guess, I'd still give you full marks. Okay, but I know a little bit more about derivatives, so I can probably draw an original. But there's no rule that maybe the original isn't x squared. Maybe it's 2x squared minus 3. So the derivative would be 4x, and this graph would be steeper. But I'm just guessing at what the original is, and that will help me guess a slope. But it's still a guess. So I'm not going to lose too much sleep if your graph is slightly steeper or not quite as steep. If it's really outrageous, like you draw this, I might challenge you on that. Or if you draw one that is super, super steep, I'm going to say, really, do you think that that parabola is really skinny? Okay, because a skinny parabola would get me this. This looks like a regular parabola. So I might challenge you on that. But if it's this, you know, versus this or this, if you're just a little bit off, I'm not going to lose sleep on it. Next. And by the way, if you do have a question, like I said, don't be afraid to interrupt. A great way to interrupt is just push the hands up button and I get a little signal that you're asking a question. Okay, now the next one, again, I'm going to use my experience to say this looks like a cubic. So I'm going to guess the derivative is quadratic. This is also a positive cubic. Okay. Looks like it's going off like this, jazz hands, which means the derivative would be a positive quadratic. So I'm going to guess it's going to look like this. This is all helpful information when I'm drawing it. But I'm going to start by going to the zeros. So here's the spot where the original graph flattens out. So the slope of the tangent is 0. And here's another spot where it flattens. So the slope of that tangent is 0. Then I do my pencil test. Again, I'm trying to show you on the screen. You know, there's my pencil. Pretty steep and positive. It's going up, which means my graph is going to start up here. And then the numbers get still positive, but get smaller and smaller and smaller. This slope here is smaller. And so it's still a positive number, but I'm getting smaller and smaller and smaller, which is good because I eventually got to get to 0. Then I do my pencil part for this middle section. And the middle section is all negative. You see how the graph is going down. These slopes are going down. They're going down. So the middle section of this graph is all going to be below the x-axis because my slopes are negative. And they start with kind of being small and then get steeper. But I'm going to ask myself, where along this middle section is it steepest? So this middle section here, where is it steepest? Well, I think it's steepest right here in the middle. And that's not a surprise, right? You can kind of see that it kind of gets steep and then it starts doing a snake and going back and less steep. So that's going to be the spot where I know my derivative is going to be down, have the biggest number, the steepest number, which is down in the negatives, somewhere down here. The big challenge that we had when we did this by hand and in the game was knowing how far down it goes, right? You could go down to maybe -3, maybe -2, maybe -4. On the game, I was a little bit picky because it was fun, but on your test, as long as you have a reasonable number, chances are you're going to get it perfect, okay? So it's hard if you want to try and actually do a slope and do a rise over run and try and figure out that it's, you know, like this and it's down 2 over a half, and maybe that suggests it go to 4. If you want to do that, you can, but as long as it's a reasonable guess, you're getting full marks. So I think it's going to go somewhere down here as the steepest part. So it's still negative, but then it gets to its steepest part. Then it stays negative, but it's getting smaller, which means the graph is coming back to 0. Still negative, but getting smaller. You can see that the steepness there is less of a number. And then it gets to eventually 0. Then, of course, it switches and it becomes positive, which means my graph now is on the positive side of the axis and getting steeper, right? This is not so steep, steeper, steeper, which means the graph is going like that. And it does give me that quadratic shape, which I predicted. So I'm going to estimate that as a pretty good graph. Again, though, if you gave me something that went down to 4, as long as it goes through these points, I'm happy. Okay? That would get you full marks as well, or something a little shallower. What am I not going to be happy with? If you do something like this. And now you're saying the steepest part of the graph is over here, which is not. Okay? It's got to be in the middle. All right. And then our final one is kind of one of the first derivatives we drew. because the slope is constant the whole time, the derivative is constant. So in this case, you can actually calculate the slope. Probably hard to see on the screen, but on your page, you can see it goes down 1, 2, 3, and over 1. That's down 3 over 1. So the slope of this guy is 3, and you can calculate this. You can be accurate. Here you are guessing slope. Here you know the slope. So I know the slope is -3. So I'm just erasing that slope triangle so I can draw it. And I'm going to go down to -3 and draw a straight line. Because it's always -3 here, 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 here. The slope is always -3 on that graph. And it goes all the way up till this point. But we learned that the point can't have a derivative. There's too many tangents that touch it at one spot. So I'm going to have an open circle there. And now the second half of this graph, this particular one seems to be the same steepness. Looks like up 3 over 1. So it's +3. So I'm going to go to +3, 1, 2, 3, open circle, and it's always +3 no matter where I am on that graph. Let me get that shape. Okay. All right. Questions? Okay. So lots of explanation there. I think as I go through and start doing questions, I'll probably more lecturing and going a little bit faster for the rest. So number 3 is still the first unit, which means we didn't know all the rules. We didn't know product rule. We didn't know quotient rule. We didn't know power of a function rule. We didn't know any of those. Although our spidey sense told us that we might know some of the answers. So this is from first principles. The question says that, which means we're going to have to use our limit notation. The y prime is equal to the limit as x approaches 0. No, h approaches 0, excuse me. Of f at x plus h minus f at x all over h. Okay, that's our formula from derivatives from first principles. So what we do is we take x plus h and sub it into the equation wherever there was an x. So it used to be 4x squared, so now it's 4x plus h squared plus 5. That's me plugging in x plus h. Now I'm going to plug in x. And of course, when I plug in x for x, it's going to get exactly the same thing all over h. And I'm hoping someone over there is saying, Mr. Lee, you forgot your limit sign. That would be bad, because I would lose marks for that. All right, now it's a matter of doing our rainbow. X plus h squared, you might do that off to the side. X plus h times x plus h. Rainbow, 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 rainbow. X squared plus 2xh plus h squared. We've done that lots, so I'm not going to spend too much time here. X squared plus 2xh plus h squared plus 5. These square brackets we've come to love. They're really helpful, especially later on when we do the chain rule. So just keeps everything in their spots. Now I'm going to rainbow the x, or the 4, excuse me. I only rainbow the 4 within the bracket, so that means the plus 5 is on its own. Now I'm starting to drop the brackets, which means I'm subtracting both of these, which means it's like a little mini rainbow of subtraction. Minus 4x squared minus 5 all over h. At this stage, the constants should disappear. So plus 5 minus 5, That's good news that it disappears. If you forgot to rainbow the negative up here, and this was a plus, they wouldn't cancel. So the good news is that's going to be a little red flag that maybe you made a mistake. So I did that. Is there anything else that's going to cancel? Yes. Anything that doesn't have an H should cancel as well. So luckily those are going to cancel. That's going to leave me with this little part here, which I'm not going to rewrite, but it's 8x h plus 4h squared all over h. Now that I divided everything else canceled, I can divide everything by h. So that's a 1, a 1, and a 1. And that'll leave me with the limit as h approaches 0 of 8x plus 4. Now that I've gotten rid of the h on the bottom, I can evaluate the limit. I can take the limit by substituting h equals 0 in. Oh, wait, this is 4h, excuse me, because only the square disappears, so it's 4h. Now I can evaluate the limit. Oh, since I'm evaluating the limit, I don't need the h anymore. So 8x plus 4 times 0, which is just 8x. And that is y prime. The really good news about us doing a Unit 1-2 test is we actually knew the answer before we even started doing all this. We look back in the question and use the rules that we know to be true now. If I just went off here and asked you what y prime is, you would tell me it's 8x. You know that right away. Okay, so you know what your answer is going to be. The only difference is this is asking you to do from first principles, which means you're pretending you don't know that. Okay, but you do know it, so you do know what your answer is. So that's kind of a little bonus that you know what the answer is going to be and you can get that. Okay, now I'm going to do B. That first one was A. Now I'm going to do B. Same strategy. Y prime equals the limit as h approaches 0. F at x plus h minus f at x all over h. But of course this time it's a fraction one. So it's 2 over x plus h minus 5 minus, and then just plain old x is what's there, all over h. Since it's fractions, we know we need to find a common denominator. And the most obvious common denominator is the product of the denominators. So here we're going to actually combine them by finding the common denominator of x plus h minus 5 and x minus 5. That's our common denominator, the product of the two denominators. X plus h minus 5 and x minus 5. Don't rainbow those together or anything like that. You're going to make your life harder than it needs to be. But then I ask myself, what do I multiply by this to get this? And you can see it was x minus 5. And so the top has to get multiplied by x minus 5. So there's a 2 up there, and it has to get multiplied by x minus 5. Same question here. What did I multiply by this to get this? And it's x plus h minus 5. So the top, which is also a 2, is x plus h minus 5. All over h. The whole purpose of me doing a common denominator is so I can bring it together into one fraction. So bringing it together into one fraction, keeping that denominator, is that. So on the top, I'm going to do a couple of steps here. The top is 2 bracket x minus 5. I'm going to rainbow that. as I'm bringing it together. So that's 2x minus 10. And then I'm subtracting this rainbow. Since I'm subtracting, I'm going to rainbow negative 2 and a rainbow negative 2 into the second part. Okay, since I'm subtracting, it's technically subtract and then you rainbow 2, but then later you're going to bring the negative in as well. So you might as well bring the negative in now and rainbow a negative 2. So by rainbowing a negative 2, I end up with minus 2x minus 2h plus 10, because it's a negative times a negative 5, all over h. Again, if you forget that or do it in a couple of steps, that's fine. But if you forget, a big red flag will pop up. Because if I forgot to bring that negative in, this would have been a minus. And then I'd have a minus 10 and a minus 10, which does not cancel. So that would have been a little red flag that something I did was wrong. But I did it right, so my minus 10 plus 10 is going to cancel, as will my 2x and my minus 2x. That means it's going to leave me with only a minus 2h on the top. And then it's all being divided by h. At this point, I'm going to bring this h up. Since I'm dividing by h, I'm going to multiply by the reciprocal, which is 1 over h. So this becomes times 1 over h. By timesing by 1 over h, we now see the spot where the h's are going to cancel. H there, canceling, divided equal 1. And I'm left then with the limit as h approaches 0 of negative 2 over x plus h minus 5 and x minus 5. Now at this stage, I can substitute in h equals 0 without fear, which means I can take the limit. I can take that, I don't need to write it anymore, it's negative 2 over x plus 0 minus 5, x minus 5. Well, of course, x plus 0 minus 5 is just x minus 5. And this is where you'll see that I have two of them, x minus 5 squared. This is good news for me because, again, I'm writing this test having already done Unit 2, so I knew that this was going to be the answer. I knew it was going to be the answer because it's the quotient rule, and the quotient rule is the bottom squared. So even if I wanted, just off to the side, I could go off and do the derivative, the quotient rule here. The quotient rule would say, derivative of the top, well, derivative of 2 is just 0, times the bottom, x minus 5, minus the derivative of the bottom, which is 1, times the top, all over the bottom squared. Right there, I can see my x minus 5 squared, so that's good news. On the top, I got 0 times that, so it's gone, and then I just have a negative 1 times a 2. And I can look and see that that is what I got the long way. Okay? You do not have to do both. I'm just saying because you have the advantage of knowing Unit 2, you can check your answer from Unit 1 and know that you did it correctly. Okay? So those are the two, those questions are going to take quite a bit of time just because of all the steps. The next probably longest one is going to be when you do the chain rule because those ones you saw were a little bit longer. But from here on, we're now using Unit 2. And we're going to just start taking derivatives. Questions? All right. Okay, so in number 4 on your review, this will also be where I don't know if it's going to be on the, actually, when I think about it, this might sneak onto page 1, kind of like how it did here on your review. So I originally said page 1 was going to be just unit 1 and page 2 is going to be unit 2, but I'm thinking the derivatives might sneak onto page 1 like you have here. So, but starting at question 4, we're now in unit 2 and we're going to start using the rules to differentiate. So the first principles only have to be done in question 3. So now it's just a matter of taking the derivative. So you'll see that I've copied some of this, so I'm going to bounce back and forth. I'm going to do A and F on this screen, so I'm not going to do it in order A, B, C, but that's okay. All right, this one is probably the one you're all going to love, and we're going to get 100% of the people getting it right, because it's just using the power rule. 2 comes down, gets multiplied by the 4, which is x, and then to the power of 1. It's 1 less, probably won't write that down. And then the derivative of negative 6x is just 6. And we're done. So that's, well, that question. Just found the derivative, done. F. F is obviously a bigger jump than B is, but let's go to it. First thing I'm going to notice, a couple of things. I'm going to notice the square root sign. So I don't know how, I don't have a root function power rule or quotient rule or anything like that for root functions. I don't have any differentiation rule for functions or root functions, which means I have to change it into an exponent. So I'm changing it into the exponent 1/2. Remember, the square root of something means to the 1/2. If it was the cubed root, it'd be to the 1/3. The 4th root would be to the 1/4. So I change it to an exponent because I do have differentiation rules for exponents. But before I get to that, I have to slow down. And this was an example of one that we had yesterday where people were trying to bring the 1/2 and multiplying it by x. Just by hearing that you're multiplying by x, you should recognize that x is a function, not a coefficient. If this was a 7, sure, bring it down and multiply by 7, but you can't multiply by x. Multiplying by x is a clue that you have 2 functions. I see the x function as being the first one, and this whole other thing as being the second one. And I'm multiplying those together. If you look here, you see I actually have 2 functions here. This is the first one, and this is the second one, but I am subtracting them or adding them. This is the sum rule in number 1. We don't need any fancy tricks for that. We can just differentiate the first, plus or minus differentiate the second, no problem. But when I have the 2 functions being multiplied as I do in F, then I've got to use the product rule. And the product rule, you should hear my voice in your head. The derivative of the first times the second plus the derivative of the second times the first. So I'm going to do that here. I get to switch colors so that knows. So now you know I'm doing my calculus. So I'm going to also do it over here just to give me some space. It's the derivative of the first, and the derivative of x is just 1 times the second. X squared plus 1 to the 1/2. Don't change it. It looks exactly the same as the second. Plus the derivative of the second. And the derivative of the second is a power of a function rule. And this is the one we threw on the board a whole bunch of times and where we kind of forgot about it because we got so distracted with the chain rule and everything else. You know how to do this. This is the Russian doll. Derivative of the outside times the derivative of the inside. The outside you see a 1/2. So that comes down. X squared plus 1 to the negative 1/2. That's the derivative of the outside. Times the derivative of the inside. And the inside, the derivative is 2x. All of that is the derivative of 2. Times the first. So I can't forget that I'm in the middle of the power rule. I'm in the middle of the power rule, which says derivative of the first times the second plus derivative of the second times the first. And this is where it gets a little bit hard to keep track of where you are. So just remember that I'm in the middle of the power rule, but when I differentiate the second, I got to take a pause and remember I've got a rule just for that. That's the power of the function rule. Do it, then go back and say, okay, I'm still in the middle of the power rule, so I'll clean it up. Here you've done the calculus. This is your calculus line. The rest is just simplifying. Obviously, times 1 isn't going to change the question here, so that makes it a little bit nicer. But I do see a 1/2 times a 2x times an x. That's an easy thing I can multiply by. So 1/2 times 2, 2/2 is just 1, so that's gone. X times x is x squared. And this is not an easy thing, so I'll leave it alone. And that would be an acceptable answer. Now, on the review, did I leave this written like this? Yes. Yeah, so there's matches the answer on the review. Questions on that one? Okay. Moving on to B. So you see B, of course, is easier than F was, but we'll just do it right now. Am I going to panic? So let's just go backwards to A. I'm 100% confident we're going to get 100% people getting A right. Bring this down, da, 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 da. Just because there's a fraction in B doesn't mean we panic. It's exactly the same multiplication. Here I brought the 2 down and multiplied by 4. So in this one, I'm going to bring the 2 down and multiply it by 3/2. 3/2 times 2 is 3. If you're uncomfortable with that fraction multiplication, do it off to the side. Do some scrap. 3/2 times 2, which is 2/1. How do you multiply fractions? 3 times 2 is 6/1, which is 3, not 2, which is 3, which is where I got that number. Okay? I actually did it in my head by saying the 2 and the 2 cancel, and I'm left with 3. That's another way to get it. There's no shame in writing off some of that multiplication of fractions off to the side. I'm not a big fan of you going into your decimals because decimals like 1/3 are not nice. So I'd rather you have this. But if all else fails, do it in decimals so at least you can do your stuff. And then anyway, that's all this first differentiation. Then it's -1. The derivative of 1 is 0. It's not done this question. Next then, I'm going to do G. G definitely looks different. But you should see, again, 2 functions. A first function and a second function. But of course, each of those functions have their own little rules. This first function is something to the power of 3. Blah to the power of 3. Russian doll. Derivative of that is going to have its own rule. All right, I'm giving myself lots of room, so I'm going to start over here, y prime. Okay, so now I'm going to start over here. Equals. Actually, I'm going to do it in green because I'm doing calculus, so stick with my plan here. Y prime. Derivative of the first. So the first is something cubed, which means I do this. Okay, I'm Russian dolling this idea within a Russian doll. Okay, I got something cubed, so it's 3 to the blah squared. So the inside stays the same. Till I've done that, then I open it up and I got to look at the inside and I differentiate the inside. The inside is 3x squared. All of that is simply the derivative of the first. This is where I snap back out of that and remember that I'm in the product rule. And the product rule is the derivative of the first times the second. So now I gotta go times x squared minus 3 to the power of 4. I'm already nervous about running out of room, so I'm just gonna move everything over a bit more. Again, I can't forget where I am. I'm in the middle of the product rule, which is the derivative of the first times the second. Plus, now I gotta differentiate the second one, just like I differentiated the first. So 4, x squared minus 3 cubed, times the inside. What's the derivative of the inside? 2x. All of that is the derivative of the second. I'll even underline it to remind myself that's all the derivative of the second. But I'm in the middle of the product rule, so I gotta finish by timesing it by the first. There's all my calculus. There's my big line. At this stage, I would advise you to just go back and make sure you've done it all. When you're in the middle of doing it, it's easy to lose track of where you are. But when you have the big picture, it's easier. Derivative first. Let's see it. 3, yep. Inside, yep. Didn't forget the squared like I did yesterday, so that's good. Times the second. Second looks the same. Then derivative first. Yep, 4 and a 3, and then inside is a 2x. Good. Times the second. Or times the first. Now it's a matter of cleaning up. Only clean up when it's simple. So in this case, I got a 3 times the 3x squared. That's a simple thing. This squared and this 4 is too much. So I'm only going to clean this up and say 9x squared. Everything else I'm going to leave as is. Plus, over here, find things that are easy to clean up. 4 times 2x. Everything else is going to be harder to clean up. So 4 times 2x is 8x. And then x squared minus 3 cubed. And we got that. At this stage of our journey, that's going to be an acceptable answer. And I think it matches what's in the back. I hope. Oh, it does. Good. Okay. This has been the best snow day ever, sitting here listening to Mr. Lee ramble. Well, that's all right. Okay, C. See, I'm going to differentiate. Use the power rule again. Geez. This looks like A, B, and C all look like the same. Right? Just using this rule. A, B, and C all look the same. I don't care if it's a fraction. No big deal. Derivative of this. Bring that down. 2 times a half is 1. Oh, not x squared, x. And then again, the constant is just 1/4. It's a constant. I don't care if it's 1/4 or if it's 1. It's still the derivative of that 0. And so look at that. There's that one done. Again, if you wanted to see that math that I did here, I have 1/2 times 2, which is 2/1. That's 2/2, which is 1. Or they cancel, you see it's 1. Now I'm going to do H. So H is a quotient rule. This really jumps out at you. Product rules should jump out at you. Quotient rules really will because you see that big fraction. And the quotient rule, again, you should hear my voice in your head. Derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. So, the derivative of the top, that's just x. The derivative of x is just 1. Times the bottom, as is, minus the derivative of the bottom. Well, x squared minus 1, derivative of that is just 2x. Times the top, which is x, all over the bottom squared. Don't hesitate, take a pause. Did I do that right? Derivative of the top is 1, yes, times the bottom, leave it. Minus derivative of the bottom, that's 2x, times top, x, all over the bottom squared. Don't bother rainbowing at the bottom. You're always going to have a bottom squared. Leave it as is. Top we clean up when it's easy. This is an easy rainbow. You're just multiplying by 1. And here, this is negative 2x times x. This is all easy simplifying, so we'll do it. X squared minus 1 minus 2x squared. This is just a minus 2x times x. Or you can think of it as cover this up, 2x times x is 2x squared, and then you're minusing. No rainbow here. That's rainbow only happens when there's a plus or a minus in between. All over the bottom squared. And I'll notice that I can simplify x squared. And so I had negative x squared minus 1 all over x squared minus 1 squared. And that is my derivative. By the way, you'll notice that in H, the function was defined with the notation f of x. So your derivative should say f of x, or f prime of x. In C, it was defined by y, so your derivative was y prime. If for some reason you make that mistake and you write down y prime here when it's actually f of x, and y prime here when it's actually f of x, I'm just going to laugh and say, be careful, but I probably won't take a mark away. Depending on who it is. You know who you are, who I'm definitely taking a mark away. But probably I'm going to say, be careful, and then just let it slide. All right. Questions? All right, let's keep going. Okay, in D, right, we're going A, B, C. D was getting a little bit more complicated because it brings in this root sign. So let's try and simplify that. Again, I'm not doing calculus yet. I'm just simplifying. So the square root of x can be changed to x to the power of 1/2. Now we've made the question technically as simple as C, as simple as B, and as simple as A. The only difference is the thing we're bringing down, this was an x squared, we were bringing down, this was an x squared, they were all x squareds. Here's not an x squared, it's x to the 1/2. But don't panic. You can differentiate this, no problem. You can bring down the 1/2, no problem. I'm going to bring down the 1/2 and multiply it by 5. 5 times 1/2, that's 5 halves. I'd rather you write that a fraction than the decimal, because if it's a third, you're going to get a really weird number. What was that math that I just did? 5 times 1/2, which is 5 over 1. Multiply the top or the bottom, it's 5 halves. Next, x minus 1. Well, we've done this a number of times. We actually already did it in the review. It's 1/2 minus 1, which is 1/2 minus 2 over 2, which is negative 1/2. You've probably done enough of these to remember that 1/2 minus 1 is just negative 1/2. And then the second part of this function is minus, and I differentiate that as an old school 12x squared. Just bring the 3 down, multiply by the negative 4, and do 1 less. I'm fine to leave it like that. You could convert it back to root functions, but you'll see my answer is left like this. If you wanted to convert it back, it would look like this. Negative tells you to make it a fraction. 1/2 makes it a root sign. Since it's a fraction, it goes on the bottom with the 2. So you could write it like that, but I will accept this as an answer. I'm a little nervous about this one fitting on the page. Yeah, so I think I'm going to go and do I on the next page. So, my argument is if you could do H, then you should be able to do I. Now I know it's longer, but that's all it is. It's longer, not harder. It's no different rule, it's no anything else. And it's just a longer polynomial, and you're good at differentiating polynomials. So take the confidence that you actually can do this one, even though it looks harder. Rule is still derivative of the top times the bottom minus derivative of the bottom times the top all over the bottom squared. The only catch is when I differentiate the top, it's going to look a little longer. So y prime, derivative of the top, 2x plus 2. Neat, didn't take me too long. Differentiate the tops, no problem. Bottom, x squared minus x minus 12. Leave it as is. Minus. Derivative of the bottom, again, looks tough, but it's just longer. Derivative of x squared is 2x, derivative of minus x is 1, and the 12 disappears. So it's just 2x minus 1. Times the top. All over the bottom square. Which again is looking tough, but it doesn't matter because I'm not going to rainbow this. Just going to leave it as is. Now, one of the tough parts about this, or not tough, but longer parts about this, is my rainbow is going to be a little longer. It's still what I would classify as an easy rainbow, so we are going to simplify. But of course, since I'm rainbowing a trinomial, it's a lot of rainbows. As a result, I think I'm going to give myself even more space. So I carefully go off and do each rainbow. 2x times x squared is 2x cubed, minus 2x squared, minus 24x. That was me rainbowing 2x. Now I'm rainbowing 2, plus 2x squared, minus 2x, minus 24. That's all that rainbow there. In the second part of the rainbow, a couple of ways you could do this. I'm rainbowing 2x minus 1, but there's also a minus. It can be very tempting to try and rainbow the negative in there at the same time. We did it someplace else. So right here, we used the negative and rainbowed it. I think in another spot, we rainbowed the negative at the same time. I can't remember when it was. The catch with this one is you're not just rainbowing like a -2 or a -2x, you're rainbowing a 2x minus 1. So I think I'm going to slow down and I'm going to put all this as the answer to the first part. And then I'm going to slow down and just do the answer to the second part. So the second rainbow, I'm going to do it pretending that I don't see that negative. It's too easy for me to make a mistake. So I'm going to just do it in brackets. So now I'm going to rainbow. That's 2x cubed plus 4x minus 6x. Now I'm going to rainbow the -1. -1x squared minus 2x plus 3. You might agree with me that, you know what, it's too easy to make a silly mistake there. So that's why I've slowed down and haven't rainbowed the negative in yet. I'll do it on this next 9. It means it's going to be a bit more writing, but I'm okay with that. I'm also going to double check that I haven't made a silly mistake. Oh, and I see a silly mistake. You'd think I maybe even did this on purpose. 2x times x squared is 2x squared, or 2x cubed. Then 2x times 2x is 4x squared. See how easy it is to make a silly mistake. Then 2x times -3 is -6x. Then I check my negative, negative, positive. Might as well check the first one. I don't know if I double checked it. Looks good. Now, had I not caught that mistake, something would have gone wrong later on. Like my things wouldn't quite work out as nicely. So it's not the end of the world if you don't catch a mistake, but it's best to check that mistake now. All right. Now I have a big thing, subtract another thing. So I'm going to subtract everything here. That means I'm going to rainbow this negative in every single time. So 2x cubed minus 2x squared minus 24x plus 2x squared minus 2x minus 24. Now I'm going to start rainbowing the negative. So this becomes minus 2x cubed minus 4x squared plus 6x plus 1x squared plus 2x and minus 3. Can definitely see what I'm talking about, how this question is just longer, but not necessarily harder. But of course, when it's longer, it introduces more opportunities for you to make a small mistake, like I did. Okay, but we're careful, we can double check, and then we've saved ourselves. Now I'm going to collect like terms. This is where underlining or crossing out or something like that is a great strategy. Notice that 2x cubed minus 2x squared cubed is gone. That's exciting. I even have a minus 2x squared and a plus 2x squared. That's gone. But those ones are left over. So that's minus 3x squared. Next, I'm going to look at 2x, negative 2x, and then a plus 6, and a plus 2x. So they're there, minus 2x plus 2x, that canceled. But it did leave me with just a 6x. And then I'm left with, wait. Again, you guys should be yelling at me. And this is where my underlining helps out. I missed this guy. I knew if we were in class, you'd be yelling at me. So I've got, this isn't that, it's, there we go. Okay, I got a 24, a minus 24, and a plus 6. That's going to be a minus 18x. Then I've got the minus 24 and the minus 3, that's minus 27, all over x squared minus x minus 12 squared. And it looks like that's the same as the answer. Now, you'll notice on the answer sheet, a little common factoring happens. If you notice on the top, there's a negative 3 that's common to all of them. So the answer sheet does rainbow out or take out a common factor of this and say x squared plus 6x plus 9 all over x squared minus x minus 12 all squared. That's just a luxury thing. That's like making it look pretty. I will accept the green answer there, even though the answer on the sheet has the negative 3 common factored out. Bringing out a common factor is going to be important in later units. That's probably why I did it here, because I'm so used to doing common factors, but you don't need to at this stage of the game. I'll be happy with you stopping at the green line. Questions so far? We're definitely getting to the long parts of this, so we'll keep going. You can see why I decided to spend this whole day. Even if we were in class, we would have spent both periods doing the review because there's lots to practice. Okay. In the next one, again, I've tried to say this a couple of times. A, B, C, D, and E are all the same rule, trying to look tough. Okay, the exponent's just changing, the coefficients are just changing. But in this one, it's just fractions. I know just fractions sounds frustrating, but it's something that we are okay with. We can do fractions. So we can do this one. I have to bring that 3/4 down and multiply it by -4. there's no harm, like I said before, in writing that down someplace. This is -4 times 3/4. You need to write it down there, no problem. When you multiply the tops and multiply the bottoms. So that's -12/4, which is -3. Or you might recognize that this is going to cancel, this is going to cancel. It's just -1 times 3 and get -3. So bringing this down and multiplying by that 4 is okay. It's just -3x to the something. What's that something? Well, it's 3/4 minus 1. To subtract 1, I need a common denominator, 4/4. 4/4 is the same as 1. Keep the denominator, subtract the numerators, it's -1/4. You're able to do it with 1/2. I've seen you all do it with 1/2. 3/4 is different, but it's the same strategy. You can even imagine on the number line, 3/4 is over here, and if I take away 1, I'm only going to be 1/4 into the negatives. And so this is -1/4. The second half, I'm now rainbowing a 2/3, a -2/3. Or not rainbowing, but bring it down. This is where if you go to a decimal, you're really going to struggle. So on this guy, it's -3 times -2/3. Again, you might see that that is over 1, that's negative, or that +6/3, which is 2. Or you might see that this is canceled and you get -1 times -2, it's just 2. So bringing that down is +2. It's a negative being multiplied by a negative, that's why it's 2. Now I have to subtract. Well, I'm going to have to subtract something else which isn't too pretty. -2/3 minus 1. Again, there's no shame in me writing this down over here. Of course, when I'm talking thirds, ones is 3/3. And now this is keeping the 3, and it's -2 minus 3 is -5. And so this becomes -5/3. And all of this stuff here is probably scrap paper off to the side, and you will have scrap paper when we're doing this. And I think, again, I leave it as that, and so we're fine. And I know it's hard for me when I keep saying that A, B, C, D, and E are all the same question. It's the same rule. The only difference is the calculus isn't different. The calculus is exactly the same. The only difference is we're doing some fractions. Okay, but that's not calculus. Okay, J. I need to redo J here, so I'm just gonna copy this. All right. J is another example of the Russian dolls and being able to try and keep all of your rules straight and go systematically through step by step. Okay, so just try and imagine that that's that. Also try and imagine a question that looks like it that's easy. So sometimes you'll see me do this just off to the side. I'm going to say this is actually kind of like x to the power of 5. That I know how to do. It's 5x to the power of 4. The only catch is it's not an x. It's this whole thing. But my first step should look like that. That's a good little strategy just to kind of calm your nerves a bit and say, oh, this question is trying to act tough, but it's not as tough as I'm giving it credit for. So again, just give myself some space and say that this is J. So the derivative is 5 blah to the power of 4. Just like I pretend it was an x, 5x to the power of 4. except it's not an x, it's of this thing. And since the inside is not just an x, it's a function, I also then have to differentiate inside. So the Russian doll idea comes in, I did the 5 on the outside, then I go and differentiate the inside. And of course, when I go off and differentiate the inside, it's like its own little question. It's its own little quotient rule question. So I'm going to ignore all this sort of stuff and just pretend that the 5 is not even there. And just do the quotient rule, because we did that pretty successfully earlier on. So derivative of the top times the bottom minus derivative of the bottom times the top. Derivative of the top, 2, times the bottom minus x minus 1. Minus derivative of the bottom, which is just 1, times the top. All over the bottom square. And this is where you start to realize that this is actually 2 easy questions put together trying to make it look tough. So then I'm going to simplify. So right now I'm just going to leave this big garbage over here as is. And I'm going to simplify just the second part of this. Like its own little question. So times 2x minus 2, I'm rainbowing at -1, so it's minus 2x plus 1 all over x minus 1 squared. By rainbowing, I see that the 2x minus the 2x is going to be gone, and I'm going to left with 5, 2x minus 1 over x minus 1 to the power of 4, times, and then -2 plus 1 is -1 over x minus 1 squared. This is a pretty good answer, but when I look at the answer sheet, it doesn't quite line up with what I thought I would get for an answer. And I'll show you the next couple of steps that gets to the answer sheet. So the next couple of steps is to say, you know what? I actually see an x minus 1 on the bottom here and an x minus 1 on the bottom here. Is there any way I can kind of bring those together? And the answer is yes. I can bring them together by saying that this fraction is being raised to the power of 4. When you have a fraction being raised to an exponent, both the numerator and the denominator get that fraction. I can rewrite this as 5. I'm going to write it as a fraction too, 5 over 1. But the top gets the x to the power of 4. So 2x minus 1 to the power of 4. And the bottom is going to get the x minus 1 to the power of 4. And then this just stays the same. So all I did was I changed 5 to a fraction 5 over 1. But I took that 4 and put it to both the top and the bottom. By doing this, I now see fraction, fraction, fraction being multiplied together. So the top can all be multiplied. 5 times 1 times this garbage. And then the bottom can be multiplied. Well, 1 is not going to change anything, but this is x to the power, x minus 1 to the power of 4, and x minus 1 to the power of 2. Notice that those are powers with the same base. So I'm going to keep the base and add those exponents. And it becomes x to the power of 6. And that's how we get to our final answer. I'm just going to pause for a second. Someone's at my door, and I'll be right back in 1 minute. Okay. Okay. Good. Okay. No, that's good. Yeah, I think. Okay. So. Right?
Yeah.
All right, good seeing you. Take care. And I'm back. Any questions about this guy?
What happened to the -1 on the top?
Oh, perfect, thank you.
Yeah, I had the same question.
Yeah, and so what's my mistake? What am I missing in my answer?
Do you have to change the 5 to a negative?
That's
Or just
right.
put a -1?
Yeah, because it's 5 times -1, so that should be -5. To that. Great question. Does it now match our answer? Yeah. You see the answer has just a -5 out front. I decided to make it as a fraction and put it on the top. But of course, either of those would be right. All right. Are we done differentiating? Oh, no. Yes, no. Yes. We've done everything from number 4. So we were stretching our legs. And we can see, you can tell that number 4 is going to be a big chunk of your test. It took us like 45 minutes just to do those questions. Now, it's not going to take you as long because I was talking and explaining everything like that. But a good chunk of your test is going to be number 4. So when we switch over to the back, we get the last few questions. And the last few questions are chain rule. And then my favorite, find the equation of the tangent, or the slope of the tangent, and then equation of the tangent, and then kind of a thinking question at number 8, which we're going to do now. Well, we'll do 5, 6, 7, 8 now. Okay. So chain rule, this is from yesterday. I am going to need to take the derivative of each of them on their own and multiply those answers. It looks like it's a tough one because you're putting in x equals √5, but when you actually put that in, it's going to make your life easier. There's a reason why I gave you that kind of weird x value. All right, I know that I need to do some substituting, but I'm going to save that, so I'm just going to leave myself some space for substituting later. I'm going to go down halfway here and start doing my derivative. dy by dx is dy by du times du by dx. Chain rule allows me to break up complicated ones into smaller, easier functions. So here's a function, here's a function. The u function is to the square root. So I'm going to change that right now to the 1/2, much like we did in number 4. So when I come to differentiate that, it's going to be a little bit easier. Now, dy by du, that's the y function by u. So just plain old differentiate 2u minus 4. Strongly encourage you to take advantage of the square brackets to keep yourself organized. Times now du by dx. And that's this function here, which is something to the power of 1/2. So I rush into all this and I see it's something to the power of 1/2. So it's 1/2 comes down and the exponent becomes -1/2. And the inside stays the same until I'm actually ready to look inside that. That's not +1, that's -1. So that's the outside is bringing the 1/2 down. Then I differentiate inside 4x. That's the derivative of the second u function. Now, I simplify when it's easy, but don't stress too much about simplifying. Like, don't do too much rainbow or anything like that. Simplify where it's easy. To me, it's easy to see 1/2 times 4x. So I leave everything else the same. 2u minus 4 dot, and then 1/2 times 4x is 2x. Times 2x squared minus 1 to the -1/2. I don't see anywhere else where I can rainbow or do any easy stuff to simplify, so I'm not going to bother. But that that's the derivative, but I didn't ask for the derivative, I asked for the slope of the tangent or using it at x equals 5, or root 5. So x equals root 5, then I know what I'm going to put in the second half, but I don't know what I'm going to put in for u. So that's why I left myself some space here. And I'm going to go 2 root 5 squared minus 1 all over the square root. Well, the reason I gave you root 5 is I knew you'd be squaring it. And when you square it, root 5 squared is just 5. So then this becomes 2 times 5 minus 1. 2 times 5 is 10, minus 1 is 9, square root of 9, and 3. So that means that u equals 3. So I'm going to take u equals 3 and plug it into the first part, and I'm going to take x equals root 5 and plug it into the second part. By the way, I'm done calculus. I'm now just plugging in numbers. So don't try and apply any more calculus rules or bring exponents down or anything like that. Just go off and do it. 2 times 3 minus 4 times. Now I'm plugging in root 5. So 2 times root 5 bracket 2 times root 5 squared minus 1 to the negative 1/2. Just make sure I don't go too fast here. All right, in the front I got 2 times 3, which is 6, minus 4. You probably could have just gone straight to 2 there, but whatever. 2 root 5. Now, on the inside of this bracket, I think I can do some of this in my head. Root 5 squared. Root 5 squared is going to be 5, right? Square root of 5 and then square it, of course, comes back to 5. So that's 5 times 2, which is 10, minus 1, which is 9. So it's 9 to the 1/2. I got too many brackets there, don't I? It's okay. Now, hopefully you remember your exponent rules from grade 11. So you could actually figure out this number on its own. It is 9 to the 1/2. Negative 1/2 is 1 over 9 to the 1/2. 1/2 is square root, so it's 1 over the square root of 9. So it's 1 over 3. You could go to your decimal, or your calculator, but it's going to give you a 0.3333. So this whole part changes to 1/3. That's from the black work that I did over there. This is a 2 root 5. And the front here is 6 minus 4, which is 2. Now I'm multiplying. I can see these are all fractions. So on the top I got 2 times 2 root 5 is 4 root 5. And the bottom I have 1 times 3, which is 3. That's not a great answer, because it is a little bit of a challenging number that got put in. I'm not saying that this one's not going to be on the test, but I'm going to try and make it so that the thing you substitute gets down to maybe a little bit nicer number than that. Okay? So just as a heads up. All right. Chain rule in the second one. I actually think the second one's easier than the first one for a number of reasons. One, I don't have a big root sign, I only have a small one. And also substituting in x equals 1, which makes my life a little bit easier. But it is a longer one. And then I've got a y function, a u function, and a v function. So again, halfway down here, I'm going to leave myself some room. dy by dx is dy by du, stepping stone of using u. U uses v, you can see that, u uses v. And then v uses x. Each of these can be made a little bit easier. U to the square root of u can be made easier by making it, u to the 1/2. This can be made easier by doing a little mini rainbow. So this is y. This is 3v minus 2v squared. That can be easier. And then v is just x squared. Actually, this brings me to one of the points that I wanted to make sure I stressed. So we know that one of the first strategies I gave you for differentiating is if you can make your life easier first before you differentiate, do that. So here's an example of me doing that. By rainbowing v, which is pretty easy to do, I've made my differentiation a little bit easier. So when we were doing it and we were learning the other rules, sometimes I said, don't do that because I wanted you to practice the rule. But here, you know all the rules, and it's your prerogative if you want to take advantage of any of the rules at any time. So in this particular case, it is going to be easier to differentiate. Don't think that I'm going to force you to do the product rule here, because there's one function and there's another function. I'm not going to force you to do that. If you see that it's easier to rainbow first, that will make your differentiation easier, go for it. If you don't, and you want to use a product, that's fine, it's just going to be longer. Okay? But only do it when you can. This question sounds a lot like one that we did before, and I want to go back to the one before and see why didn't we do this earlier. So I'm going to go, I think it was the first one. Yeah, like right here. This kind of looks like the same one, the x times this. Why didn't I rainbow here to make my life easier? Well, I can't, because this second half has an exponent. BedMath tells me I have to deal with that exponent before I multiply, so I can't rainbow here. So I had to use the product rule in F. But here I am later on doing the chain rule, and I was given some function where I could rainbow. You see how this doesn't have an exponent? So I could rainbow and make my life easier. So you have permission to make your question easier before you differentiate. Anywhere on this test. Okay? All right. So the blue stuff I've done to make my life easier. Now I can go off and differentiate each little question. So the first is dy by du, which is u to the 1/2. So I'm going to go 1/2 u to the negative 1/2. I've done that a number of times. I think we're good with that. Dot. And then du by dv, that blue function is pretty easy to differentiate. It's 3 minus 6v. Way easier than doing the product rule. Times, and then the v function is even easier. It's just x squared. The derivative of x squared is x. Hey, Lauren.
Hi, I just had a question on how you got 6v from minus 2v squared.
That's a really good question because it doesn't make any sense.
Yeah, I was confused.
What should it be? What was my mistake?
Negative 4v.
Oh, that's right. I did 2 times 2 and said it was 6. I obviously got excited with the 3 and I did 2 times 3 wrong. So thank you, Lauren, for interrupting. or not interrupting, raising your hand. Yeah. Thank you. All right, so that's 4V, good. You can see why I think this one's easier because the differentiation is much easier than the previous one. Now I'm going to go off and substitute. I don't think there's any simplifying I can do anywhere here that's going to make my life easier. Definitely don't rainbow this X's and V's. That's going to make your life harder. All right, so I'm ready to start substituting. I've got X equals 1. I can substitute that. But I also need a V. So a V is going to be 1 squared, which is just 1. So V equals 1. So I'm substituting that. But it's not just V that I'm substituting, it's also U. So if V equals 1, then U is equal to 1 minus 3 minus 2. Oops. 1 times 3 minus 2 times 1. So I'm plugging in V equals 1. One times 3 minus 2, which is 1, so U is 1. Total coincidence that all of them ended up being 1. I'm actually going to check to make sure they all equal. Yep. Just a coincidence. Okay, it's not always going to be all the same number, but it's great. This makes my life easier because the number I'm substituting here is 1, which is much easier than some of the other ones. All right, so let's go off and plug in. X equals 1, V equals 1, U equals 1. 1/2 times 1 to the negative 1/2. 3 minus 4 times 1. And 2 times 1. 1 to any exponent. Doesn't matter if it's a negative or anything like that, it's going to be 1. 1 to any exponent is 1. So 1 times 1/2 is just 1/2. That's all going to simplify to 1/2. This is 3 minus 4, which is negative 1. And this is 2 times 1, which is just 2. 1/2 times 2 is 1 times negative 1. And we get that the derivative is negative 1. The slope is negative 1. So we're going to be cheering for one like this on our test as opposed to the first one, but recognize they're both about the same. All right. We're now moving on to 6. Find the slope of the tangent to the given curve at the indicated point. So this sounds like something we did in Unit 1, and it is something we did in Unit 1, but we're doing it in Unit 2, which means we're going to be able to do it a lot quicker. In Unit 1, we would actually be estimating the slope of the tangent at 2 by putting in 2 plus h into our limit function, right? F at 2 plus h minus f at 2 all over h and taking the limit like we did before. But that was before we had all the rules. Here we have the rules. So we're just going a step further, and in fact, it feels like what we just did. You're going to differentiate, then substitute a number. Okay? So don't make these any harder than they are. Find the slope of the tangent of this. Of course, to find slopes, I have to take the derivative. The derivative of this is 2x minus 5. Simple, simple. Except I now go a step further, and I sub in x equals 2. So now, remember, the derivative represents all the slopes, and I want the specific slope at x equals 2. So this is where I change from y prime to an actual number, 4 minus 5, negative 1. So the slope is negative 1. Really, this question is exactly the same as number 4, except I'm now giving you a point to sub in. It's a spot to practice differentiation. You take the derivative, plug in a number to get an actual slope. So the questions are going to feel very similar. You see how C looks an awful lot like one that we've already done. Yeah, well, it kind of looks like F, I guess. Looks like this one here, where we did in the chain rule. So this is the third time we've seen the square root of something. Chances are you're going to see it tomorrow too, or on the test. All right, let's differentiate. Before I differentiate, I'm going to make my life easier by calling this 5x plus 1 to the 1/2. So that means y prime equals 1/2 5x plus 1 to the negative 1/2 times the derivative of the inside. Again, you can see this power of a function rule popping up over and over and over again. Okay, so we got to make sure we practice that. We can make our life a little bit easier by doing the 1/2 times 5 here. So that's 5 halves. If you didn't see that simplification and just subbed in x equals 3 on this line, that would be fine. But I made it a little bit easier, and I'm going to sub in at this stage. So now it's m, because I have an actual number. Five times 2 is 10, plus 1 is 11. Ooh, that's not nice.
Don't you sub in 3 instead of 2?
Yeah. Phew, thank you. I got 2 from the other question, didn't I? Still not great, though. Oh, it's plus, too. Jeez, struggle is real here. So 5 times 3 is, oh yeah, 16. Okay, good. Phew. So you can see where my mind was going there, right? Like I was getting these weird numbers. I'm not saying you can't get a weird number, but on the test, I'm probably going to give you a number that works out a little bit nicer. So 16 is much nicer than 14 or 10 that I was getting before, or 11, I think it was, because 16 is a perfect square. And I see that I'm being raising it to the 1/2, which means I have to take the square root. So I'll just show you that math there. This is 5 over 2. The negative tells me to do a reciprocal, and the 1/2 tells me to do the square root. So that's from grade 11. The negative tells you to make it a reciprocal, put it on the bottom. The 1/2 makes it a square root. So then now I can see that it is 1/4. And I can multiply across and get 5/8. We should be able to do this simplifying from grade 11, the 1 over root 16, so that you get an answer of 5/8. If you go to your calculator, you're going to get a 0.25. And then you multiply it by 5 over 2 is going to get you some decimal. I prefer the fraction answer. All right. Almost done. It's been long, but that we're good. Again, B and D. Oh, look at D, looks just like the one we just did before. Wow. You can see where this is a good practice. But anyway, we'll do B really quickly. The quotient rule. Derivative of the top is 0. Right, derivative of 2 is just 0. Times the bottom. That's going to make my life easier. Minus derivative of the bottom, which is 1, times the top. All over the bottom squared. Not substituting now because I'll make my life easier. 0 times this is 0. That's going to leave me with negative 2 on the top over x minus 1 squared. Now I'll sub in x equals negative 1. So that's going to be negative 2 over negative 2 squared. Let's go over here. Negative 2 over 4, which means m is negative a half. Get that right? Yeah, cool. Questions on that guy? All right, and D, I'm going to do really, really quickly, if you don't mind, because it's exactly the same as 4J. It's the same idea. So I'm going to do it relatively quickly. It's just we're going to go off and substitute in a number afterwards. So copy. All right, so I'm just going to buzz through this really quickly. 2 bracket the 1 x squared minus 4 over 3x minus 5 times the derivative of the inside. So the inside is a quotient rule. Derivative of the top times the bottom minus derivative of the bottom times the top all over the bottom squared. I will simplify a little bit before I rainbow, or before I substitute. Simplifying is rainbowing a 2x and a negative 3. So 6x squared minus 10x minus 3x squared plus 12 all over 3x minus 5 squared. Six x squared minus 3x squared is 3x squared minus 10x plus 12 all over 3x minus 5 squared. You may see the same thing that I saw before in that these have the same denominator. So I could do some simplifying, but I think I'm a little tired. So I think I'm just going to plug in 1. I'm just going to make sure I've done this correctly though. Hate to make a mistake. Yeah, so I think I'm going to plug in 1 now. The advantage of having a number to plug in is you don't have to simplify down as far as you normally would. You can start plugging in a number. The more you simplify, the easier the substitution becomes. But I'm going to plug in x equals 1. So now 2. 1 squared minus 4 over 3 times 1 minus 5 times 3 times 1 squared minus 10 times 1 plus 12 all over 3 times 1 minus 5 all squared. Two times minus 3 on the top, minus 2 on the bottom. Here I've got 9 minus 10 plus 12 all over negative 2 squared. Negative divided by negative is positive, so I'm going to leave that as 3 over 2. This is 2, that's 11 over 4. And now I got 2 over 1, so 2 times 3 is 6, times 11 is 66 over 1, 2. That's 2 times 4 is 8, which I think is 33 over 4. How confident I am about that. Yeah, good. Page's ratings there, yeah, good. Help me out, where did I go wrong?
Where did you get the 9 from?
That's where I'm wondering myself. Oh, good. Thanks, Paige, for finding my mistake. The 9's wrong, right? It's 3 times 1 squared, and I did 3 squared. So This is where I got tired and started making mistakes. But I probably would have at this stage gone back and make sure, double check things. So Paige has found my mistake there, so it's 3. So this is gonna be a 5 now, I think. So this is 30 over 4, which I think is 15 over 2. I think that's right. Yeah. Oh. I love the sound. I'm going to fix my own mistake before you do. Mr. Lee, 2 times 4 is 8. 5 by that is 4. So thanks whoever dinged in to tell me that one. All right. Okay. We're doing well. Only got 2 questions left. Next it says find the equation of the tangent to the curve blah at x equals -1. So in order to come up with the equation, I need to have the derivative to get the slope, and then I'm going to go off and use that slope to figure out a point. So first thing I need is, in order to do this, I need y equals mx plus b, so I need a slope and a y-intercept. The slope's the first thing that's going to come to us. So I'm going to have to differentiate this function. Already I see something to the power of 6, blah to the power of 6. Russian dolls, I see that 6 there, bring the 6 down, subtract, and I got 6 blah to the power of 5. Of course, I leave the inside alone right now. Times. Now I go off and do the derivative of the inside. Russian doll. Outside, inside, bring it in there. 2x minus plus 3 is the derivative of the inside. I could simplify a little bit. I could do 6 times this. That'd be a little mini rainbow. I don't think I'm going to because I'm going to substitute in a point. So I'm going to plug in that x equals -1. Because I need to get the slope. Remember, my goal is to get the equation, so I need the slope. So I'm going to take this x equals -1 and plug it in here. So the slope is 6 times -1 squared plus 3 times -1 plus 5 to the power of 5 times 2 to the -1 plus 3 -1 squared is 1, plus 3 times -1 is minus 3, plus 5 squared times -2 plus 3, 6 times, this is going to be 3? Yep. Times 1, that's 6 times 9, which is 54. So the slope is 54. Anna.
What'd you do to the power of the 5 to get to the power of 2?
That's a great question. I did something wrong. That's what I did.
Oh, okay. I was just confused. I was like, okay, did I miss something?
You're not the confused one. I am. Thank you. This is the math teacher on the second hour of his marathon. So there we go. Anna's correctly told me that I've done that wrong. So that's a 5. 3 to the power of 5. Yeah. That's pretty big. I don't even have that step here. Was it 3 to the power of 5? 243 times 6, 1, 4, 5, 8. All right, I'm not gonna panic. It's a decent number, makes kind of sense. I got something to the power of 6, so I have a pretty steep graph. There's my slope. I'm gonna take my slope, and then plug it into y equals mx plus b. So I know it's y equals 1458 x plus b. Now I got to figure out my y-intercept. To do that, I'm going to sub in a point. But guess what? I don't have a point. I only have a coordinate. I only have a spot. Where am I going to get my y? And I remember you guys doing this up on the whiteboards, and people are like, give me a y. Or can someone, do you have a y that you can borrow? Where do I get this y? I get the y by plugging it into the original equation. Okay, we plug it into the original equation to get our y value. This should look familiar. I feel like we've already done this part over there. So this is going to be 1 minus 3 plus 5 to the power of 6. I'm not going to make that mistake again. So this is 3. 3 to the power of 6. It's to the power of 6 now because I'm not doing the derivative. I'm just doing the regular number. 3 to the power of 6, that's 729. So that means my coordinate is -1, 729. And that's what I'm going to plug in. So the y value is 729. 1458 times -1 plus b. 729 equals minus 1458 plus b. Add 1458 to both sides, and I got 2187 equals b. And now I have my slope. Y equals 1458x plus my y-intercept. And we get that. Remember I said that I want my questions to be nice, like end up as reasonably nice numbers. I consider this nice numbers. Even though they're big, okay? But they're not like super bad fractions or anything like that. So don't freak out if you are getting a slope of 1458. You might want to just double check, right? You saw I made a mistake by dropping the 5, changing the 5 to a 2. So there's no harm in going back and looking over this. We have one period to do this, but if for some reason you need more time, I will give you more time. Because I want you to make sure that your first experience here, you're able to have time to go off and simplify as needed. All right. Let's do our final question. And maybe some of you have been just waiting 2 hours to get to this last question. And thanks for hanging with me. Anna.
So, like, how much longer is, like, how long is the test going to be?
It's designed to go during one period.
Okay.
Which we're going to start in the morning then. If for some reason you need to go into break, you can do that. And if you need to go a little bit longer, you can. Okay, I'm not going to, this is the luxury we have of having 2 periods back to back, that if you need some extra time, it's easy. Okay? All right. So the last question here is a bit of a thinking question. And you should know that thinking question is something that I definitely am going to have on there. So while this is a new question that we haven't practiced, it does involve stuff that we've done before. You can expect a thinking question at the end of your test as well. Something that seems a little bit different, that you might need to do some fiddling with, but use the calculus or the explanations of the calculus in order to answer. So this question says, find the points on the graph where the slope is given. So if you just think back 2 questions ago, this question here said, find the slope of the tangent at the given point. So I gave you the function, you differentiated, you plugged in the point, you got an answer. This question is doing the opposite. It says, here's the function, here's the answer. What's the x value? So if I was to work backwards in this question, I would differentiate, but I know that the answer is -1. So I would go here and say the answer part is -1. And I would have to work backwards to figure out what x is. So if I work backwards here, this is going to be +5, so it's going to be 4 equals 2x. Divide by 2, divide by 2, 2 equals x. And look at that. That's what it is. Okay? So what we're doing in this question is working backwards. You're still going to differentiate, but I'm going to tell you what the answer is. You work backwards to figure out the x. I'm going to erase this because this is not what we do in 6, but it does sort of show you what we're going to do in 8. So the function is 3x over x minus 4. We're going to differentiate that. You can see there's lots of practice of the quotient rule on this review. That's so you're in good shape for the test. Derivative of the top is 3 times the bottom, minus derivative of the bottom times the top, all over the bottom square. I'm going to simplify before I do anything else. So rainbow, 3x minus 4, and then this is minus 3x, or x minus 4 squared, and then 3x minus 3x is gone, and I'm left with -4 equals x minus 4 squared. That's the derivative. That's the thing that tells me all the slopes. In this question, I'm telling you one of the slopes. You have to work backwards to get the actual answer. Laura.
I think the middle value might be -12.
Look at you being really polite. I think it might be -12. You are correct. 3 times -4 is -12. All right. Thank you. So this is the derivative that represents all the slopes of tangents. I have a slope of tangent. I want to know what the x value is that gets me that. So just look here. Here's the slope, here's the derivative. -12 over x minus 4 squared equals -12 over 25. Dun, dun, dun. Luckily, Lauren fixed my mistake, so I would see that this almost looks exactly the same. The question is, what x value is going to make this derivative turn into this fraction? I think it's safe to say that the top is the same. That's good. So the only way this could be the same is if the bottom's the same. So that means the only way this could be correct is if x minus 4 squared equals 25. Now you might be able to just look at this and figure it out. That would be fine as long as you explain it. But notice that what number should I put in for x here? That when I subtract 4 and squared, it equals 25. So I think the thing in the bracket has to be a 5. So 5 squared is 25. So what value for x is going to get me a 5? I see that 9 is the value for x that's going to work. Now, there is some math I could actually do here. Square root of both sides. And I would see that one of my answers would be x equals 9 like I predicted. But there's another number that's going to get me a 5 in here that's going to square, because the square root of 25 isn't just 5, it's plus or minus 5. So there's another number that's going to work, and that is x minus 4 equals negative 5. So x equals negative 1 is also going to work. You can go back and check it right here. If you put in negative 1 minus 4, that's going to get you negative 5. Squared is positive 25. So you can see why this is a good thinking question. It still involves all the calculus we did. There's still all the calculus we did in green. But we have to kind of think and fiddle to get our answer. And in fact, I can see a difference between a level 1, 2, 3, or 4 on this one. Level 3 might only see the 5 or the 9 as the only answer. Level 4 will see that there's actually another one that will work as well. Okay? Level 2 is maybe you just get the derivative, but you don't make the connection between the derivative and that. And level 1 or 0 might be having trouble with the derivative or don't know where to start. Okay? This little math that I did here is the technical way to do this, but I would, since it's a thinking question, you might do some explaining as opposed to that and say, I can see that 9 is an answer because 9 minus 5 squared is 25, and say x equals 9. So there would be some English to explain it, which would be fine. Of course, I would like you to explain the other possible answer, which is negative 1 minus 4 gets you negative 5, and that works as well. So you don't have to memorize any perfect math here. You're fiddling, you're thinking. That's the advantage of the thinking question. All right. So this is extra textbook questions. This has been posted on Google Classroom. Personally, as I've always said, you know that I'm the one who makes up the test. So I'm the one who makes up the review. So I would say the review is more important than textbook questions. But I know some of you like to do more practice. So there is more practice here. All right. So this is where I'm going to stop the recording. But if anyone wants to hang around and ask any questions, then they can gladly do that.